So let's look at data minimization, which is another method of data protection. Data minimization reduces risks by limiting the sensitive information we maintain in our organization. And how this works is the organization only keeps data that is still needed for business use. Any data that is no longer needed for business use is deleted or destroyed. And so the best approach to data minimization is destroying data when it's no longer needed. Data minimization is carried out through 3 different methods, and that's destroying, de-identify, and obfuscate. So you destroy the data, you either destroy the data, or you de-identify the data, or you obfuscate the data. So let's look at each of them. Destroy the data. Remove data when it's no longer needed for business purposes. It's as obvious as it states. When data is no longer needed for business purposes, remove it or delete it. Then de-identify. So what is de-identification? This refers to removing any links of data to individuals. So we try to remove any links data has to specific individuals, which reduces the data sensitivity. So that's de-identification, and that's why we try to de-identify, to remove links to individuals, reducing the data sensitivity. In that, even if it lands upon a malicious person, they cannot relate it to any individual, so it's no longer as sensitive. Then we can also obfuscate the data, where we transform the data so the original information cannot be retrieved. Yes, we transform it into a new value that cannot be related to the original value. So we are going to look at data obfuscation in more detail, since it's heavily used in data minimization. So the methods of obfuscation, as I said in the previous slide, obfuscation is heavily used in data minimization, and how it's done is through hashing, tokenization, and masking. Through hashing, tokenization, and masking. So what is hashing? What hashing does is it transforms our values using a hash function into a new hash value. So we have our original value, we apply a hash function to it, and it generates a new value. A new value which is referred to as a hash value. And that new value cannot be related, or it cannot, when someone sees the new value, they cannot relate it to the original text or the original value. Then we have tokenization. This where this refers to replacing sensitive values using unique identifiers using a secure lookup table. To explain this a bit, can be like, let's take an example where we have a student ID number, and we generate a random 10-digit code to represent our student ID number. But then we keep a table that can help us transform this randomly generated code back into the student numbers when needed. So when a normal average person whom we don't want to know what this information means comes and lands upon this generated code, they cannot know what it represents and what it's used for. But the fact that we have a different table or a lookup table that we can use to transform these generated codes back into student numbers, we can be able to use this information. The problem with tokenization is you have to make sure you keep the lookup table very secure, because it's what maintains our system very discrete. Next, we have masking, which is the most obvious one, which refers to partially reducing information by replacing portions with blank characters. For example, you have a credit card numbers and you replace the last 4 digits with X's or asterisks. That is what we call masking. So the obfuscation methods we have are hashing, tokenization, and masking. Though hashing is not heavily advised to be used due to the fact that it's subject to rainbow table attacks. Let's look at those in the next slide. So, what are the hashing limitations? Hashing is subject to rainbow table attacks. How are these rainbow table attacks carried out? Attackers compute hash values to check against your data file. For example, imagine that we have a file listing all the students at our college who have failed courses, but we hash their student IDs. So hiding their student ID, we create a new hash value for their student IDs. If an attacker has a list of all students, they can compute the hash values of all student IDs, then check to see which hash values are on the list. For this reason, hashing should be used with caution or in addition to other security measures. So, hashing, since another person can apply the hash values and get to compare the hash values to the list, they can get to know what you're hiding. So hashing is not as obsolete and as secure as we would like it to be.